Hey everybody, this is the notes for 8.6. Microphone would help. This is the notes for section 8.6. This is the irrational number e and change of base. So on your calculator, you have a little button that says, oh, pen. Doesn't say oh, pen. It says e to the x. Okay, looks like this. This is the button you want to use in this section. You cannot survive this section without your calculator, just so you know. So if you don't have it in your hand, go get it in your hand. Okay. All right, so first we want to start by graphing this function. So essentially what we're going to do is we're going to make a little table. Okay, you're going to put in your calculator e, and then, sorry, probably what you're going to do is put in -2 and then hit the e to the x key. Depends on your calculator. And you're going to get some sort of value. For -2, it should be 0.135. For -1, it should be 0.368. At 0, it should be 1. At 1, it should be 2.718. Or sorry, at 1, it should be 2.718. That's what I said. And at 2, it should be 7.389. We're going to graph that. Okay. It looks basically like this. Okay. This looks kind of familiar, doesn't it? It's an exponential function. Okay. You could also graph it +1. Essentially, what's going to happen here, different from the first time, is that it's going to shift the same way we knew our exponential, our function shifted before. A shift like this is just up 1. So it just moves my curve up. E is a number, is an irrational number. And it's one of the things that we do with functions like E is things that compound exponentially. Okay. So this all feels sort of disconnected, but it'll all make more sense as we go. One of the things that we do is we can calculate compound interest. Okay. We're going to use E in a minute, which is why we just talked about it briefly. But in this formula, and this is a formula you need to remember, it's like the second one. Okay, we did what? Quadratic formula in this one, basically. This is for compounding interest. P is the principal, it's the amount you start with. R is the rate. That rate should always be as a decimal here. Okay, N is the number of times it's compounded per year. T is the time in years that you have your money invested for. Okay. If one of the options, so typically for compound interest, it's yearly or monthly or daily or weekly or whatever, or twice a year or 4 times a year, quarterly. One of the things that can happen though is interest can be compounded continuously. It just means it's infinitely, it's always compounding. When that is the case, the formula changes and we use E. Okay, so we use P as the initial principal, the amount you started with. R is the rate, still a decimal. And T is the time in years. It's a simpler formula, but the idea of compounded continuously is just a little bit of a different thing. If you find a bank that will compound interest continuously for you, you should go there. All right, so let's use the formula. So first it says you invest $5,000 in an account earning 6.5% interest. Find the balance after 10 years under the following compounding options. So if it's compounded annually, so what you're going to do is you're going to set up your formula. Okay, this is not continuously, so we're going to use this formula back here. So I want to find the amount in 10 years. Okay, the number of compounding periods, my N, is just 1. Okay, because 1 year. And my rate is 6.5% as a decimal, so 0.065. My principal I started out with was $5,000. All right, well, I have all my things because I know time is 10 years. So I'm going to write $5,000 times 1 plus 0.065 over 1 to the power of time, 10. Or 10 times 1, technically. Okay. So you should be able to do this in your calculator. In your calculator, you would do 0.065 divided by 1, or whatever that is, plus 1. Okay. Then to the exponent, then multiply by 5,000. Be careful of your order of operations here. When you are finished, you should have $9,385.69. Okay. Now we're just going to change the compounding period. So instead of yearly, it's going to be quarterly. So instead of n equals 1, quarterly means 4 times a year. Everything else is the same. So after 10 years, I have $5,000 compounded 1 plus 0.65 divided by 4 times 10 to the power of 10 times 4. Okay, so once again, I'm going to do 0.65 divided by 4, then add 1, then to the power of 40, then times 5,000. I get a little more money when I compound more often. I should get $9,527.79. I like it. All right. Compounded monthly. The difference here is going to be that n is 12 instead of 4. Okay, follow the same process. Compounded daily. The difference here is what? That n is 365. Okay, 365 days in the year, same process. And the more often it compounds, the more money you should be getting. So if you get to 365 and suddenly you have less money than you did earlier, something's wrong. Okay, and then when we get down to here, this one says compounded continuously. So now we shift a little bit the formula. So what we're going to do is my amount after 10 years equals the principal, P, times E to the rate as a decimal, 0.065, times time. Okay. When you do this in your calculator, you'll put in 0.065 times 10, then use the e to the x key, and then multiply by 5,000. When you're done, you should get $9,577.70. That's your best option. It's not your best option. It's not a ton better than what you should have gotten for daily, but hey, every little bit counts. And the more money you save, the more money you earn. Life is good. All right. This is another example for you to try. The more you practice this, the better you will be at it. For A, when you are finished, you should have $1,477.46. For, no, E, not that one. For compounded continuously, you should have $1,491.82. Everybody else should be between them. If you get stuck in the order of operations somewhere, please say so. Let's talk about it, okay? Sometimes you really have to practice this on your calculator to be good at it. This is the part in the semester where people get stuck on things like on the final later where you lose points on something that you just shouldn't be losing points on because it's calculator work. So please do take the time to practice this because it will matter for you. It will save you some time and pain later. All right. So a natural log is written as y equals ln of x. You have that on your calculator too. You have ln. I was trying to write ln as one letter, and it's ln of x. Okay. ln of x is just a log base e. That's it. Okay, so I could write it like this, or I could just write this. These mean exactly the same thing. Okay. I can also graph the natural log. I would do this basically the same way. Okay. I would make my chart. Okay, I'm going to do -2, -1, 0, 1, 2, 3. What you're going to find, though, is when you put in negative values for the natural log, it's not going to work. You can't have natural log values that are less than 0. Okay, so it's the inverse of an exponential function. It's an irrational number. All sorts of things go wrong in there. So we just don't do that. So what you're going to find is this is 0. Sorry, I'm not going to do 0 either. I'm going to do 1. At 1, it's 0. At 2, it's 0.69. At 3, it's 1.09. At 4, it's 1.3 something. I can't read my own writing. Okay, so what happens here is it's sort of that curve. It's the inverse of what we had before. It's the shifted 90 degrees. Okay. All right. So what's interesting about natural logs and E is that basically the things we can do with natural logs and with e works exactly like what we were doing with logs before. Okay, so we just did in 8.5 all of these properties with logs. We see them exactly the same thing here, same thing again, okay? Not gonna hurt us. So what we need to know here is that ln of 1 equals 0. Essentially, it's saying that the natural log of e of 1 is 0 because e to the 0 equals 1, just like everything else, okay? If I have log base e of e, that's going to be 1. Well, because e to the 1 equals e to the 1. This works the same way as the others. You can rewrite them in exponential form, same as we've been. None of that changes. It's just log base e. The other thing that's true is the properties for product and quotient and powered that we've been using also apply here. So ln and log are just sort of interchangeable ideas, okay? So I can expand and contract just like I was doing before. So we're going to do some simplification. The first one is ln of e. Well, we just did that. It's really like writing the log base e of e. And I want to know what that equals. Well, e to the something equals e. It's got to be 1. So that has a value of 1. ln of 1 is the same as log base e of 1. So e to the something's got to get me 1. Well, anything to the 0 power is 1, so this has got to be worth 0. All right, well, let's try something else. E to the x plus 1. Well, this is really like log base e to the x plus 1. We know when these guys match, the value is just whatever that exponent is. Truth. Same thing here. ln of e of x plus 1, or e of ln of x. E to the ln x plus 1. Whew. What happens here? Well, you tell me. I just get x plus 1, don't I? I should. Okay. All right. So you can go through and try these. I should get 2 here. For this one, I should get 0. For this one, I should get x plus y. For this one, I should get 3x. Okay. Try them. Make sure you can figure out how they work. And then just like we did before, we can expand and contract. So I want to write these as a single log, just like I did before. I see 2 negatives. That means I'm going to write this as ln x minus 1/3 ln y plus ln z. Those are both going to be in the denominator. So 1 log, 1 ln, okay? X in the numerator, y to the 3rd in the denominator, and the z. We know that the 3rd is really just the cube root. So cube root y, z. We've done that before. Doesn't that feel pretty familiar? Okay. This guy you can try. When you are finished, you should have ln, which I try to keep writing as 1 letter, a to the 4th, or the 4th root of a, c over b. Okay, remember that this b right here is what's being subtracted, so that's what goes in the denominator. All right, I can also expand. I still want to expand this one. It's just slightly different. I need to rewrite that y, just like I did before, x squared y to the half. All right, so I have ln of e minus ln of x squared minus ln of y to the half. So I get ln of e minus 2 ln x minus half ln y. It could have been this, but I just wrote it as minus minus, whichever is fine. Remember, though, that ln e is something, isn't it? ln of e is log base e of e, right? Isn't that just 1? So really, it's 1 minus 2 ln x minus half ln y, okay? So where you see things to simplify, you should actually simplify them. This one is, again, we're going to write as a summer difference. Okay. So I have, let's see, 3lnx plus, I'm going to use that y as a half, right? Half ln y minus 2ln e. Well, I know ln e is the same as 1. So I'm going to get 3ln x minus half ln y minus 2 times 1 is just 2. Okay, that's fine. The last thing we have to do in this section is something called change of base. So here's the thing. Sometimes in your calculator, you want to calculate the log of some base of some number, right? But you only have a button in your calculator for log base 10 or ln a log base e. And if it has some other base, you're kind of stuck. But actually what gets to happen is you can do this in your calculator. This is called the change of base formula. Essentially what you do is we treat this as log base 10, we can choose whatever base we want, of whatever number, divided by log base 10 of the base. Okay? Log base 10 of the argument divided by log base 10 of the base. Gets us the answer to whatever this was. So again, calculator. So I have log base 4 of 80. Essentially what I'm going to do is I'm going to rewrite that as log base 10 of the argument, 80, divided by log base 10 of the base, 4. Okay? I can use ln, I can use e, it doesn't really matter, but you're going to calculate this. So put in 4, take the log, put in 80, take the log, find the values, divide them. Okay, you should get 3. I can't read that, 161. Okay. Try another one. We can do the same thing if we use base e. Okay, so I could do ln or log base e of 80 divided by log base e of 4. Same thing's going to happen. Okay, calculate that through. You basically get the same answer because it doesn't matter if I use log base 10 or ln e. It just matters that I use whatever one I'm using consistently. Okay, so you try these two and actually use base 10, use base e, whatever. So this one you'd use log base 10. This one you're going to use ln. Okay, so for 10, it's going to be 2.829. For 11, it's going to be 2.829 because it's the same log. Okay, so the last thing here after change of base is just an application. So we have this formula, A of P equals ln of P divided by that little tiny negative number. Find the age of bone that has 72% of its initial carbon. P is a percent when you see that letter P like that. So I'm just going to put 72 in there. So I'm going to do ln of 72 divided by negative 0.000121. Calculate. Okay. We're going to get something like 2,715 years. Okay. I have to make sure I did that right. It looks like my answer has a decimal in it in my notes, but I don't know if it does. Divide by negative 0.000121. Oh, and I have this like crazy different answer. Maybe I have too many zeros. I don't know. ln of 72. I don't know what I got. I have, wait, let's try that again. Find the age of the bone. My goodness, what just happened here? ln of 72. Okay, I'm going to divide that answer by negative 0.000121. I get a crazy answer. That's not the answer I get. I get 35344. Okay, so that's the age. It's a lot of age. Let's see if I did something wrong here. I don't think I did though. Okay. So same idea, different formula, or sorry, different guy. Find the age of the Iceman's body. So instead of 27, we're going to use 52.7. So ln of 52.7 divided by negative 0.000121. Let's see if I do any better this one. ln of 52.7, okay, divided by negative 0.023121. I'm typing out of order. What do you get? You get something in the neighborhood of 32,000 years, okay? You try this one last, see what happens. If you get stuck or you need help, come into the discussion. We will be there. If I did something silly here, and I suspect I might have, come back. Let's talk about it, all right? See you in the next module.